Deep inside Ford's engineering headquarters in Dearborn, Michigan, a dedicated team of engineers, designers, and researchers spent countless hours exploring ideas that could shape the future of the automobile. Their mission extended beyond improving existing vehicles. They were creating experimental concepts that tested bold engineering solutions and advanced styling techniques. One remarkable result of this effort was an extraordinary prototype known as the Mustang I. Unlike a production car, the Mustang I was built as a research vehicle. It served as a moving laboratory where Ford engineers could evaluate new technologies, innovative construction methods, and design concepts that might one day influence future Ford automobiles. Although only a single example was ever produced, the Mustang I quickly attracted attention from automotive enthusiasts, journalists, and engineers around the world. Its striking appearance and unconventional engineering sparked conversations about what the future of sports cars could become. Why did Ford choose to build a sports car? The answer was simple. Throughout automotive history, sports cars had often introduced new ideas that later appeared in everyday passenger vehicles. Their lightweight construction, responsive handling, aerodynamic efficiency, and advanced engineering made them ideal platforms for experimentation. The project was led by Roy Lunn, manager of Ford's Vehicle Concepts Department. Working closely with Ford's Advanced Styling Studio, his team wanted to explore a number of innovative ideas, including cleaner aerodynamic body shapes, improved driver seating positions, stronger yet lighter chassis construction, and a mid-engine layout that promised better balance, handling, and overall performance. Meanwhile, Ford's Advanced Styling Studio focused on giving these engineering ideas an equally advanced appearance. Designers carefully shaped a sleek body with a low, streamlined nose to reduce aerodynamic drag. A distinctive roll bar was integrated into the design, combining safety with a modern sporting character. The project received strong support from Ford's senior leadership, including Vice President of Styling Eugene Bourdonnais and Vice President of Engineering Herb Misch. Their encouragement allowed the engineering and styling teams to transform an ambitious concept into a fully functioning prototype. Once the overall direction had been established, the team set even more ambitious goals. They wanted the Mustang I to meet international sports car racing standards established by the Fédération Internationale de l'Automobile, FIA, while also satisfying regulations established by the Sports Car Club of America. Even though the car was never intended for production, it would be engineered with genuine racing principles in mind. To achieve maximum strength while keeping weight to an absolute minimum, engineers selected a welded tubular steel space frame chassis. Instead of relying entirely on complex mathematical calculations, they first constructed an extremely detailed scale model of the frame. This model allowed engineers to measure structural loads and evaluate stress points with remarkable accuracy before building the full-size chassis. Once testing confirmed the design, construction of the actual space frame was assigned to the respected California race car builders Troutman and Barnes. Their craftsmanship produced a chassis that was not only exceptionally light and rigid but also practical to manufacture. The next challenge involved choosing the right engine. Ford selected its compact V4 engine and 4-speed transaxle originally developed for the German Ford Taunus 12M. Although this powertrain had been designed for front-wheel drive applications, the Mustang I's engineers installed it behind the driver in a mid-engine configuration. This arrangement improved weight distribution, reduced the vehicle's frontal area, and gave designers greater freedom to create a sleek aerodynamic body. To increase performance, the engine received numerous modifications, including revised camshafts, a higher compression cylinder head, upgraded valve springs, an improved intake manifold, a revised distributor, and twin carburetors. These upgrades transformed the compact V4 into a lively engine capable of delivering the performance expected from a true sports car. With the chassis and powertrain taking shape, attention turned toward creating an equally advanced body, one that would express the Mustang I's innovative engineering while delivering outstanding aerodynamic efficiency. With the mechanical foundation complete, Ford's designers focused on giving the Mustang I a body that matched its groundbreaking engineering. Every line, curve, and opening had a specific purpose. Beauty alone was never the objective, function always came first. The design team began by producing numerous sketches, experimenting with different proportions and body shapes before settling on the final concept. Their vision featured a sleek two-seat sports car with a remarkably low nose, flowing body lines, an integrated roll bar, and carefully positioned side air intakes that supplied fresh cooling air directly to the mid-mounted engine. To transform drawings into reality, the stylists built a full-scale clay model. A lightweight wooden framework, known as an armature, served as the foundation. Heated automotive modeling clay was then applied by hand, allowing the designers to sculpt every surface with incredible precision. Using specialized measuring equipment mounted on guide rails, the team constantly compared both sides of the model to ensure perfect symmetry. Every contour was refined repeatedly until the body achieved the exact balance of style, aerodynamics, and practicality they envisioned. Once the clay model reached approval, it was covered with a special plastic film that closely resembled polished metal. This allowed Ford executives to evaluate the vehicle's appearance without the time and expense required to paint a full prototype. Finished in patriotic white and blue, the concept immediately impressed everyone who saw it. After receiving final approval, engineers began creating production molds from the clay model. The surface was carefully prepared before several layers of plaster were applied, producing highly accurate female molds. These molds became the basis for constructing a lightweight fiberglass body shell. Each mold was coated with resin before layers of fiberglass cloth were carefully laid into place. Technicians worked patiently to eliminate wrinkles and air pockets while ensuring every contour remained faithful to the original design. Additional layers increased strength without adding unnecessary weight. When the resin had fully cured, the individual fiberglass sections were removed from the molds, trimmed, and joined together to create a complete body shell. This lightweight structure faithfully reproduced every detail of the original clay model. Before construction of the aluminum body could begin, Ford wanted to verify one of the car's most important engineering objectives: its aerodynamic efficiency. The fiberglass prototype was transported to a wind tunnel, where engineers subjected it to extensive airflow testing. These tests confirmed that the body generated relatively low aerodynamic drag while directing cooling air efficiently through the side-mounted intake ducts. The placement of these intakes proved especially effective, supplying fresh air from high-pressure areas around the vehicle directly to the engine compartment. Satisfied with the results, Ford shipped the fiberglass body to Troutman and Barnes in California. Along with the body came detailed engineering drawings, technical specifications, and every component required to build the complete prototype. Project leader Roy Lunn worked closely with the craftsmen throughout the construction process, carefully inspecting each stage to ensure every engineering requirement was met exactly as intended. Meanwhile, the completed tubular space frame chassis awaited its final bodywork. The Mustang structure combined the lightweight frame with semi-unitized body panels, creating a rigid yet lightweight platform capable of delivering excellent performance. An aluminum fuel tank was installed, followed by specially designed one-piece competition seats that formed part of the vehicle's structural design rather than being simple bolt-in components. This approach increased body rigidity while reducing overall weight. Experienced craftsmen then began shaping the aluminum exterior panels by hand. Using traditional metalworking techniques, they carefully hammered and formed each panel until it matched the exact contours established by the fiberglass body. Every piece was repeatedly test-fitted before being permanently attached, ensuring exceptional accuracy and craftsmanship. Once the aluminum body was complete, the finished shell was transported back to Dearborn, Michigan, where final assembly of the Mustang I could begin. Back in Dearborn, the Mustang I entered its final stage of construction. Engineers carefully assembled the prototype, installing each component with the same attention to detail that had guided the project from the beginning. One of the first innovations fitted to the car was an adjustable pedal assembly. Rather than forcing drivers of different heights to adapt to the car, the pedals could be moved forward or backward, allowing a comfortable driving position without changing the fixed racing-style seats. The brake and clutch master cylinders were integrated into this assembly and connected through flexible hydraulic lines. A one-piece competition windshield was installed, giving the car a clean appearance while improving structural rigidity. Inside the cockpit, the dashboard featured a padded design for added safety and housed a full set of large, easy-to-read instruments. A built-in grab handle completed the functional interior. Cooling the mid-mounted engine required a unique solution. Instead of placing a single radiator at the front, engineers installed two compact radiators behind the side air intakes. Each unit was equipped with a thermostatically controlled electric fan that automatically operated whenever additional cooling was required. Under normal driving conditions, airflow through the side intakes provided sufficient cooling without assistance. The one-piece seats became an important structural element of the vehicle. By integrating them directly into the body, engineers increased chassis stiffness while reducing weight. Each seat included a built-in headrest, and the safety belts were positioned so they could be reached quickly and comfortably. The suspension system was equally advanced. Independent A-arm suspension was used at all four corners, providing excellent stability and precise handling. Coil springs and shock absorbers were combined into compact units, improving ride control while saving space. To provide strong stopping power, the front wheels were fitted with 9.5-inch disc brakes adapted from Ford's British-built console. At the rear, proven drum brakes completed the braking system, balancing performance with reliability. Steering received special attention as well. Engineers developed a compact rack and pinion steering system connected through a flexible steering shaft. The steering column itself could be adjusted several inches forward or backward, giving drivers additional comfort and control. Despite its compact dimensions, the Mustang I offered practical storage. The retractable headlights, spare tire, battery, and fuel tank were all housed in the front compartment, while the rear compartment provided access to the engine and transmission for maintenance. Large rear exhaust outlets exited cleanly beneath the bodywork, and all lighting equipment, including headlights, turn signals, brake lights, and tail lamps, was fully integrated into the streamlined design. At last, after months of engineering, fabrication, and testing, the Mustang I was complete. The moment had arrived to evaluate whether the ambitious concept would perform as well on the road as it had on paper. Ford executives gathered as the prototype made its first demonstration runs. Their reactions reflected both excitement and satisfaction. The advanced engineering solutions functioned exactly as intended, while the sleek styling attracted immediate attention. Many of the ideas developed for the Mustang I showed real promise for future production vehicles. Although experimental vehicles normally remained hidden from public view, Ford believed this project deserved a wider audience. Rather than keeping the prototype secret, the company decided to showcase it as an example of forward-thinking engineering and innovative automotive design. The Mustang I made its public debut at Watkins Glen, New York, during the United States Grand Prix weekend. Legendary racing driver Sterling Moss introduced the remarkable prototype by driving it on a ceremonial lap before the race began. The appearance generated enormous interest among racing fans, journalists, and automotive experts. Soon afterward, leading automotive publications requested the opportunity to examine the new concept. Test drivers praised the Mustang I's responsive handling, balanced weight distribution, and impressive performance. Reviewers noted that the prototype was far more than a styling exercise. It represented a serious engineering study filled with practical ideas that could influence the future of sports car design. Wherever the Mustang I appeared, it attracted enthusiastic crowds. Its futuristic styling, compact dimensions, and innovative engineering sparked curiosity among everyone who saw it. People gathered around the car, eager to learn how Ford had created such an advanced automobile. Although only a single Mustang I was ever built, its influence reached far beyond this one prototype. The lessons learned from its lightweight construction, aerodynamic design, mid-engine packaging, advanced suspension, and driver-focused layout helped shape Ford's thinking for years to come. The Mustang I proved that innovation begins with bold ideas, and that a single experimental vehicle can inspire an entire generation of automobiles.